Hi, this is Angela with Cooley Environmental Safety Training, back again with part 3 of our waste designation series. We're going to be talking about designating Washington State only dangerous waste using the book designation method. I hope you find this information helpful, and if you have any questions about waste management or waste designation, feel free to contact me. You can reach me at info@wasteandsafety.com or check out our website at wasteandsafety.com. We have a lot of great information on there about waste management, environmental regulations, and general industry safety. So again, hope you enjoy this, and thank you so much for your time. Designating hazardous waste under the federal rules is relatively straightforward. However, designating waste under the dangerous waste rules in Washington State is more complicated. The rules regarding designating dangerous waste in Washington State are found in Washington Administrative Code 173-303, Section 100, Dangerous Waste Criteria. The purpose of that section is to describe the methods and criteria for determining if a solid waste is a state-only dangerous waste or not. State-only dangerous wastes are typically going to designate for either being a toxic dangerous waste or a persistent dangerous waste. A generator must determine if a solid waste meets the toxicity criteria under the dangerous waste rules by following either the instructions for the book designation process or by using the biological testing methods. Ecology requires generators to manage their dangerous waste under the most stringent management standards that apply. Even if wastes have been designated as hazardous waste under the listed waste rules or for a waste characteristic, it still must be further designated under the dangerous waste criteria. This is necessary because it may change how the waste must be managed. A generator may be a small quantity generator producing less than 220 pounds of a listed or characteristic waste each month. However, if that waste designates as an extremely hazardous waste, or even a portion of that waste designates as an extremely hazardous waste under the state's designation methods, then if that amount is greater than 2.2 pounds, the generator status would change to a large quantity generator. The book designation or bioassay designation may be required if ecology has reason to believe that a generator's knowledge or test results regarding a waste is not sufficient for determining whether or not it should be designated or has been properly designated. So the book designation procedure. A generator may determine if a waste meets the state-only dangerous waste or extremely hazardous waste toxicity criteria by following the book designation instructions. And those specific instructions are found in the regulations in Washington Administrative Code 173-303, Section 100, Subparts 5B. This procedure requires generators to determine the toxic category for each known constituent using available toxicity data. So examples of available toxicity data given by ecology include databases such as the Registry for Toxic Effects of Chemical Substances, the Hazardous Substance Database, and the Ecotoxicology Database. More information and where you can access those specific databases is provided in the white paper that you can find on our website, wasteandsafety.com, in the white paper section. So if you wish to get more information on those, you can find it there. Basically, once you have located any toxicity data regarding the constituents in your waste, ecology really looks at only 4 test endpoints that they use to evaluate the toxicity of waste. And the 4 endpoints are a fish LC50, an oral rat LC50, an inhalation rat LC50, and a dermal rat LC50. If there are data available for more than one test endpoint, so say there is information on a fish LC50 and an inhalation rat LC50, then you have to select the value with the highest toxicity, which means it's going to be the test that has the lowest LC50. Similarly, if toxicity data do not agree on the same toxic category within the same test endpoints, so perhaps you have 2 or more fish LC50 test results, you have to go with the endpoint that indicates the highest level of toxicity, and that would be the lowest LC50 that will be used. And finally, if toxicity data for a constituent cannot be found in those reasonably available sources, that toxic category for that constituent does not need to be determined then. It's considered to have no data available for it. So what this LC50 data is used, it's used to determine the toxic category that a chemical will fall into. And they're broken up into 5 different toxic categories, with the most toxic chemicals getting an X toxic category. That is, they have a very low LC50 for all 4 of those tests. Anything below 0.01 milligrams per liter for fish LC50, 0.5 milligrams per kilogram LD50 for the oral rat test, less than 0.02 milligrams per liter for the inhalation rat test, and less than 2 for the dermal rat test. And as the LC50s or LD50s increase, the toxic category that chemical falls into goes up in the alphabet. Then the next group is A, B, C, and D, with D having the lowest toxicity or having the highest LD50 or LC50 values. If your waste contains 1 or more potentially toxic constituent, then you have to determine what the equivalent concentration for all those constituents are in your waste. So that is, you have to add up each portion of the toxicity contributed by each chemical in the waste and to calculate the waste's equivalent concentration. And you have to also calculate the equivalent concentration for a single chemical as well. And to do that, you would use this formula that's given in the regulations. So again, based on what toxic category your waste fell into, you would sum up all of the chemicals that fell into each of those toxic categories, and then you would divide them by the leveling value that you see on the lower line there. So anything that is in the X category is held at that concentration. So whatever percent your waste contains of that chemical, you wouldn't change. However, as the chemicals become less toxic, you divide them by an increasing integer. So A gets divided by 10, B group gets divided by 100, C by 1,000, and D by 10,000. It kind of puts all the different chemicals on a similar relative toxicity. So we'll do an example of a made-up waste so you can see how this works. So this made-up waste we have has silicon, copper, potassium permanganate, aluminum, and nickel in it at different percentages. And you have to calculate what percentage your each chemical is of the waste. It's how the waste is designated in Washington State. So 10% of the waste is silicon, 3% is potassium permanganate, 0.85% is aluminum, 0.05% copper, and 0.05% nickel, and the rest is just considered non-toxic solids. So using the previous table above, the first table we looked at, we would look up the LC50s and LD50s of these different chemicals, and we'll say we've gone through that using the reasonably available sources. And we found one for silicon that was an oral rat test. For copper, there was a fish test. For potassium permanganate, a fish test and a rat test. And for both aluminum and nickel, simply fish tests. And using those LD50s and LC50s, we're able to categorize, put each of those chemicals into a toxic category. So silicon, its LD50 is 3,160 milligrams per kilogram. It's a D category, goes in the D category. Copper and nickel have pretty high toxicities. They get an A, go into the A category. Potassium permanganate and aluminum, they're still fairly toxic, but not as toxic as copper and nickel. So based on the earlier table we saw, they would be put into the B category for toxicity. So using the equation for calculating equivalency concentration, you would add up every constituent that falls into each toxic category. So we had no chemicals that were considered an X category, had 2 that were considered an A, 2 that were considered a B, 0 that were considered C, and 1 that was a D category. So where we had 2 or more, we sum up their values, and then we go through and divide each group by its leveling coefficient. So those are divided by 10, the B group's divided by 100, and the D group is divided by 10,000. Add all of those up, and you get a final equivalency concentration of 0.0495%. So a person whose waste contains toxic constituents must determine its designation according to the value of that equivalent concentration. If your equivalent concentration is less than 0.001%, the waste is going to be considered non-toxic and not a dangerous waste, and just simply a unregulated solid waste. However, if the equivalent concentration is between 0.001 and 1%, the waste is going to designate as a dangerous waste and will be assigned a waste code of WT02. Now there's a group that falls in between 0.001% and 0.01% that may also be considered a special waste. And in the regulations there is a section that deals with designated as a special waste and perhaps being able to still dispose of it as a solid waste. However, it's still, until you can go through those steps, it's still considered a dangerous waste by the state. Now, if your waste contains 1% or more toxic constituents, then it's going to be considered an extremely hazardous waste and will get the waste code of WT01. Now, persistence. Persistence is another category that can cause your waste to designate as dangerous waste or extremely hazardous waste. So for the purpose of this section, we're going to say persistent waste are going to be any constituents that are chemical compounds which are either going to be considered halogenated organic compounds or HOCs, or polycyclic aromatic hydrocarbons, also often called PAHs. And so you have to determine whether your waste contains any of these persistent chemicals as well, because that could lead to another dangerous waste designation as well. And as a generator, you must determine and identify if your waste contains any persistent constituents. When your waste contains one or more HOCs, for which you know the concentrations, the total HOC concentration must be determined. And determining the total concentration is simpler than determining your toxicity of your waste. In this case, you just simply add up the percentage of your waste that is a HOC, sum them together, and that gives you a final concentration for persistence. So we have a made-up waste here that contains 3 different HOCs at fairly low concentrations. So it has 0.05% 2-chlorotoluene, 0.05% methylene bromide, and 0.15% 1,1,1-trichloroethylene. The total halogenated organic compound concentration would be 0.25%. And comparing this to the regulations, any waste that contains halogenated organic compounds at 0.01% to 1% is going to be considered a dangerous waste under the Washington State rules, and it will get a waste code of WP02 for persistence and will have to be managed as a dangerous waste. If the concentration of your HOCs is greater than 1%, then that waste is going to be considered an extremely hazardous waste and will get a waste code of WP01. The waste designation for persistence can be tricky in that a waste that contains a mixture of a single halogenated organic chemical may not designate as a dangerous waste, or may only designate for a WT0 dangerous waste. However, when you then calculate the persistence, you add up all the halogenated organic carbons in it, you may then have a dangerous waste or an extremely hazardous waste. And in the example that we used before, that waste would not have designated as for toxicity. It would have passed for toxicity. However, it's going to fail for the quantity of persistent chemicals that are in it. Now, PAHs are similar to, they're another group of persistent organic chemicals that are singled out by ecology for a persistence waste code. So any waste that contains PAHs must have the total percentage of all PAHs determined and summed to make a proper waste designation. So in our example here, if you had a waste that contained these two different PAHs, you would add up the percentage that each made up the waste to get a final total concentration and then compare it to the regulations. For PAHs, if your waste contains 1% or more, it's going to be considered an extremely hazardous waste, and it's going to designate with a WP03 waste code. There's not a dangerous waste code for polycyclic aromatic hydrocarbons. It's going to either designate as extremely hazardous waste for their persistence, or if you do the test for toxicity, it may designate as a WT02, but there's not a WP04 or anything like that for PAHs less than 1% of your waste. Now, there used to be a simpler way to designate state-only dangerous waste. Ecology created the dangerous waste tool, and they still have a version of the dangerous waste tool available on their website, and you can link to it. There's a link in the white paper that's on our webpage as well. However, in 2014, or at the end of 2014, they took out all of the toxicology data that was in there. So currently you can use it for designating wastes that are federally listed or have characteristics, but they're requiring generators to go and find their own toxicology data to make their dangerous waste designation for the state-only waste. Now, I still have a copy of the old dangerous waste designation tool that has the toxicology data in it. And if you would like a copy of that, you can either email me or email info@wasteandsafety.com, and we will get a copy to you. That tool can still be used, or the toxicity data in that tool can still be used. However, you should do a check to see if there's been anything more recently published since 2014 for the different chemical constituents. in your waste. If nothing's been published since 2014 or any LC50s or LD50s are higher than those that are in the tool, you can use the tool to do your designation. Or if the tool says there's no data for that chemical, it would be worth doing a check to see if you can find anything for it, if there's anything more current that's available since 2014. But the data that's in there now is definitely a good place to start with designating your waste. So that is basically covers the basics for designating Washington State dangerous waste using the book designation method. There are a number of steps you need to follow, and the most difficult part is locating the toxicology information. There are those databases that are available, and if you have an older version of the dangerous waste designation tool, you can certainly use that too as a source. The next presentation that we'll be giving will discuss designating Washington State dangerous waste using the bioassay designation method. And if you're in need of any waste management training or assistance with waste designation, please feel free to contact Cooley Environmental Safety Training. We also have some upcoming waste management for Washington State trainings in the next few months. We're going to be offering the one-day refresher class October 18th and November 15th in Moses Lake. And this class is for people who work at large and medium quantity generator facilities who have experience managing dangerous waste but need to maintain their annual training. This class is also good for small quantity generators who want to stay current on the regulations and how it may affect their operations. The class runs from 8 to 4 and costs $395 per person. We are offering the full 3-day class for waste management in Washington State. That's going to be December 5th through the 7th in Moses Lake. And this class is for people who work at large and medium quantity generator facilities who are new to dangerous waste management and would like an in-depth training on both the federal and state waste management regulations. The class runs from 8:30 to 4 and costs $995 per person. If you're interested in finding out more about these classes or any other classes we offer, again, please feel free to email me or you can check our webpage out at wasteandsafety.com on this training schedule. I hope this information was helpful, and thank you for your time.